Now I invite the first presenter, Mr. MWP Maduranga, who is a postgraduate student of the Electronic and Telecom Department of Morto University. His research interests include wireless sensor networks, mobile computing, and mobile communications. He has produced referred international and local conference publications to his credit. He has been a research intern of Nokia Solution and Networks, Thailand. Please, is here Mr. Maduranga, not here? Here. Then Maduranga is not here. Then Taparugas is also not available. We'll go to the next topic. Today, on solid state photovoltaic cell made from copper CuN, Cu2O, rhodamine Ci8, P-cut, thin films and carbon nanotubes as upper electrodes. The presenter is Mr. RDAA Rajapaksha. He is a PhD student in nanotechnology research at Coimbatore University. I am very happy that Coimbatore University is also engaged heavily in nanotechnology. I had the fortune of visiting Coimbatore University about 1.5 years ago when I went to the physics labs and saw some of the work that is being done there. So, it's over to you.
Thanks. Thank you, sir. Good evening, all of you. I'm Asanka Rajapaksha. My supervisor is Professor C.N. Fernando. Today I am going to present you a third generation solar cell. Our presentation topic is solid state photovoltaic cell made from copper NCU2O, rhodamine C18, PCUI thin film and carbon nanotubes as upper electrode. This is the overview of my presentation, introduction, then fabrication process along with results, conclusion and acknowledgement. This is the structure of our solar cells. This is a thin film solar cell. We use nanotechnology to enhance photocurrent enhance using nanotechnology. These cells based on the copper as a substrate, then NCU2O, then we deposited PCUI on top of the NCU2O, then create PN junction and include dye to enhance photocurrent and carbon nanotubes used as further enhancement. Before I'm going to introduce my before going to fabrication process, I'll give a brief introduction about what is the third generation solar cell. First generation solar cell is the single multi-crystalline PN junction solar cells. This solar cells based on the silicon. Then second generation solar cells is the thin film solar cells and used materials as copper indium sulfide, copper indium selenide, copper indium gallium selenide and amorphous or nanocrystalline silicon. Then we are going to third generation solar cells. We introduced dyes to the solar cells and polymer based solar cells, quantum dot sensitized solar cells and various nanoparticles included solar cells. Now we are going to fabrication process. This is the fabrication process of our solar cells. I'll explain every steps in. This is the step 1, copper oxide deposition process. we get commercially available copper plate and then it clean using sandpapers to smooth the surface. Then we using detergents and distilled water, it purify, and we used 0.01 m concentration copper sulfate to boil this copper plate to create NCO2O on top of the copper substrate. This is the already published papers using copper oxides, N-type copper oxides. This is the surface of the, this is the SEM image of the our NCO2 electrode. You can see clearly hexagonal crystalline structures appear on top of the copper substrate as a copper oxide. This is the AFM micrograph of the our copper oxides. Its grain sizes are in micro range. This is the XRD spectrum of the copper oxides. We can clearly copper oxides appear on top of the copper substrate without cuprous oxide made, without making copper cupric oxide. This is the bond nature of the NCO2O substrate. We can it clearly appears CO2O on top of the copper substrate. This is the optical property of the our NCO2O substrate. Its band gap calculated from the diffuse reflectance spectrum, and band gap nearly equal to 1.9 electron volt. Then next step, copper iodide deposition technique. We used spin coating method to deposit copper iodide on top of the NCO2O copper NCO2O substrate. We used CUI particles, and then it dissolved in acetonitrile solution to make a solution for spin coating method. Then after applying PCUI on top of the CU2O, we can see it using AFN micrograph. Then this is the FTIR spectrum. We can see clearly CU2O and CUI prepared on top of the copper substrate. This is the XRD spectrum also. It shows the copper oxide CUI and CUI on top of the copper substrate. Then optical diffuse reflectance spectrum, we can see clearly then PN junction, CU2 as N-type semiconductor and CUI as a P-type semiconductor, then create PN junction on top of the copper substrate. Then we will go to desensitization process. Desensitization process define two categories. One cathodic sensitization and anodic sensitization. When we use dye deposited on the P-type semiconductor, it can call as cathodic sensitization, and when we use dyes on top of the N-type substrate, it called as anodic sensitization. This is the dyes we use to this research. We used octadecyl rhodamine dye. To deposit dyes on top of the our PN junction, we used Langmuir-Bloger technique. This is the Langmuir-Bloger technique. Advantage of the Langmuir-Bloger technique is we can couple potentiostat with Langmuir-Bloger through, then we can apply potential and deposit dye on top of the substrate, uniform dye layer deposited can be deposited on top of the our substrate. This is the photocurrent action spectrum. Then curve A shows the